Hi, I'm Rebecca.
And I'm Chris.
And I'm Victoria. This was our bacteria research report on dog food versus bacteria.
Our question, so I did the question, and our question is, how does the amount of meat in different varieties of dog kibble affect the amount of bacteria found on a piece of dog kibble? This question is interesting to us because we would like to make a recommendation on what dog kibble has the least amount of bacteria. The hypothesis is that we think the three different types of the three different levels of meat in the kibble and ham that we're using, the more meat in kibble, the more bacteria colonies there are, and we use our data to prove that.
These are our expected graphs. This graph is the expected percentage of meat in our dog food. We thought that before grain dog food would have the least percentage of meat after our negative control, which was a plain Q-tip. We thought Innova dog food would have the next lowest, and that ham would have the highest, 100% meat. This is our combined graph of expected number of colonies versus percentage of meat. We think that our ham will have the most bacteria, and this is our expected number of colonies. So, I got the expected percentages wrong. I think Innova will be 10%, before grain 50%, and ham will be 100%. You think that the percentage of meat will increase the number of colonies. This is our combined research paper. Our main points that we found online were that bacteria survives the cooking process and could harm dogs and humans, and that humans are 4% more likely of getting the salmonella or E. coli infections if they keep dog food in the house. This is our combined bibliography with 3 of our many sources.
Our material section it shows what, who, and why, which is meaning where we're gonna, or what the actual item is, where we're gonna get it from, and what the use of the material is. And so we have sterile Q-tips, petri dishes, media, parafilm sample, our dog food, and our camera. And most of it which will be provided by Sauber. And our Y is Q-tips is for swabbing the samples. Petri dishes is for so the samples can grow. The media and agar is food for the bacteria. Parafilm is to securely seal the plates so no air so the plates will not be contaminated. The dog food are for testing, and camera is to record data by photo evidence. And next is our procedure, which is done in trials, and we pretty much do the same trial every time. You can read below what the steps are to have a good experiment and completed experiment. And yes, so here is Chris.
Okay, so this is our data table. We have our trials across, trial 1, trial 2, trial 3, then our averages. Our negative control is no dog food, so we just let the Q-tip sit out for a few seconds. Our second thing is our first dog kibble, which is Innova, and there it is. Our third is my dog kibble that I brought in, which is before grain, and our third dog kibble is not actually kibble, it is just ham.
So this is our actual graph, not our expected graph. We discovered that some of our ideas or predictions were correct, and ham did produce the most bacteria, but the percentages in this graph, since Google Docs did not cooperate, are not the correct percentages. Whoopsies. The real percentages are actually 0% for a negative control, 32% meat for before grain, 92% meat for ANOVA, and 100 for ham.
And these are just our pictures that we had. Trial 1, Trial 2, can't see, Trial 3, and Trial 4. I hope you liked our presentation. It was fun making it. Hope you enjoy watching it.